I gave you until 3 if you need it, by the way.
Thank you, Shauna.
Okay, so, and I have another appointment at 3:30 with a new client, so. But I figured 2 hours give us enough time to get situated.
I think so.
How's it been to be back on campus?
Good, Shauna. It's been really good.
Yeah.
I'm in the process of moving though, so I'm not.
Oh, wow.
I haven't been able to log in with you because I don't have any internet at my new place. But I'm
Oh,
at the library
bummer.
right now.
Oh, okay, gotcha.
It's working out.
Okay. Are you able to share screen?
Here, chapter 8. I'm sorry, this is chapter 8. Let me get to chapter previous assignments. As assignments.
When do you think you're gonna have internet?
I'm
Maybe
waiting
next
for
week?
there's some people that are living in the front house, and as soon as they're gone and they clear up the account, I'm waiting on them. I have internet as far as like the hotspot from school.
Gotcha.
It
Okay.
doesn't, I don't think it supports Zoom very well. It cuts in and out.
I see. So it's not strong enough to.
I don't think so, Shauna. I think it's strong enough. Let me share my screen. Okay, there we go.
There we go. Okay, looks like you did some of it already.
I did all of it, Shauna, but to be honest, I guessed on a lot of them. And the one that I was able to get fairly easy was this one.
Okay. So according to a website, wine critics generally use a wine scoring scale to communicate their options
Do
or
you
their
mind if we start
opinions.
on number 1, Shauna?
Okay, but I'm not seeing number 1 on the screen. So if you back up some. Okay, last year, Marion Dairies decided to enter the yogurt market, and it began cautiously by producing, distributing, and marketing a single flavor, a blueberry flavored yogurt that it calls Bluegurt. The company's initial venture into the yogurt market has been very successful. Sales of Bluegurt are higher than expected, and consumers' ratings of the product have a mean of 78 and a standard deviation of 25 on a 100-point scale, for which 100 is the most favorable score and 0 is the least favorable score. So all of this is probably going to be this part here. Let me so all of this is all context, but it's probably going to have a meaning on finding your test statistic, would be my guess if I were reading it. So I would want to keep track of this for what they're going to talk to me about later. And I need to know what is most favorable and what is least favorable, so I know which way this is going. So I'm going to pay attention to that. Past experience has also shown Marion Dairies that a consumer who rates one of its products with a score of greater than 75 will consider purchasing the product. So again, I'm going to underline that because I might need it later. And a score of 75 or less indicates the consumer will not want to purchase the product. Again, these are just things that I would pay attention to when I'm reading it, because I don't know exactly what they're going to ask me, but these are things that I need to know. Emboldened by the success and popularity. Okay, hold on. By the success and popularity of the yogurt, Marion Dairy is now considering the introduction of second flavor. The marketing department is pressing to extend the product line through the introduction of strawberry flavored yogurt, that's Strawgurt. But senior managers are concerned about whether or not Strawgurt will increase Marion's market share by appealing to potential customers who do not like Bluegurt. That is, okay, hold on. I'm got another window open and I don't know where it came from. And I really need to, there we go. Go away. Okay, I'm seeing your, is this you? Yeah, this is your background and your filter. I'm seeing your screen, okay. Okay, so they're wanting to introduce Strawgurt, right? And they're wanting to do this for me. So now I'm gonna go to my annotation options. Draw on my annotation. Okay, so let's see. That is the goal in offering the new product is to increase Marion's market share. The marketing department has proposed giving taste of both Bluegurt and Strawgurt to a simple random sample of 60 customers. So we want to pay attention to that. And asking each of them to rate the two on the 100 scale. If the mean score given by to Bluegurt is 75 or less, Marion senior management believes the sample can be used to assess whether Strawgurt will appeal. Okay, so it says prepare a managerial report to summarize the probabilities associated with this sample and considers an increase in sample size. So we need to know this stuff here, right? So it's a mean of 78 and a standard deviation 25. So let's open up your probabilities and see what they wanted. Calculate the probability that the mean score of Bluegurt given as a simple random sample. Okay, so will be 75 or less. So again, here, we're looking for the probability. So if I was gonna write this out in probability notation, this would be the probability. Remember, my X here is the score given on the flavor scale. That's my X, right? And so I'm looking for the probability that the mean score, and I'm looking for the mean. This is my, so here I'm gonna say the probability of, and I'm gonna draw. So I'm gonna say the probability of X bar, because I'm looking for the mean, to be greater than or less than or equal to 75, less than or equal to 75. And it's just about doing the calculation there, okay? With
thanks.
your Z-score, okay? So round your answer to 4 decimal places. So given by the simple random sample. Remember that our random sample was, you had 60 customers. So N here is 60. And you can put this in your calculator just for some context. In Blumen, your Blumen formula is going to be something like Z is equal to X bar minus mu over sigma divided by the square root of n. Something like that. That's kind of the formula for the test statistic. That's why they had to give us the numbers. So 75 is our X bar. Mu is 78, I believe, right? Yeah, it's a mean of 78, a standard deviation of 25. So sigma is 25 and your N is 60. So if we look and we poke that in and then we use so our command line for this is going to be something like normal CDF. From the menu, we're doing negative E99 because we're less than 75 to 70, yeah, to 75 with a mean of 78. The thing that gets a little tricky is our standard deviation, because we don't want to use just the 25. We do want to use that. But we have to use 25 divided by square root of 60 because we have a sample of 60 people. So depending on what your instructor has told you, some people will get this decimal and then they'll import it, but that's what we're looking at, and that gave you that answer. If the marketing department increases the sample to size to 160, what is the mean probability that the mean score will be? So the only difference between the first one and the second one is basically just the second one is going to have 160 where the 60 is.
Shauna, if I wanted to solve it by hand, I would line everything up to my formula as far as the sigma of the sample, the 25 over square root 60, and get that 3.2275 and put that underneath my 75 minus 78.
Right, and then what you would have to do then is since it's a z-score, then you would have if you assuming, because I didn't calculate the z-score, I can if you need me to. Let me check that. So this is going to be let me go here. And bring this down. Stop your screen share temporarily so that I can share this. So if I do that, then if you first calculate your z-score, you're gonna have something like this. This is gonna be 25 divided by the square root of 60. Which I need to delete that and move this over and close it. So this would be my Z here is not, it's 0.9, negative 0.93. I'm not sure where you got 3 point.
I got the 3 point, that's in my sigma, the 3.2275.
Oh, okay. I put the whole thing in.
Okay,
So your Z-score is 0.9, negative 0.93, basically. So if
okay.
you wanted to find that, you would do second distribution. Now, in this case, you already did the Z-score. So now when you do your normal CDF, your lower is negative E99. Oops. E99. Oops, no. Not what I meant to write. Okay. Second E99. Okay. Your upper would be your Z-score, which is negative 0.93. Your mean here, since this is a Z-score, would be 0.
Mm.
And your standard deviation would be 1. .1762. Or I could just do, depending on the constraints of your class, I could do second distribution and go from the actual data itself. The lower would be negative E99, the upper would be 75. My mean would be 78. And my standard deviation would be 25 divided by the square root of 60.
Oh, I see what you did.
So it depends on, some instructors will require you to compute the Z-score, but if you see, if you do the actual, if you do it from here, it's slightly different, but not appreciably so.
Shauna, if I punch something into my calculator and I get a negative Z-score, I did something wrong, right?
No, negative Z-scores are okay. Negative probabilities are what you would be doing something wrong with.
Okay,
Negative Z-scores mean that you're below the mean.
right.
Whatever the mean is for that. So, and then that makes sense, because if you look at what I have on the screen, when I calculated the Z-score for the data, that Z-score is negative, right?
Mhm.
And it should be, because our mean, remember the mean taste score was 75, or
Yes,
78, sorry.
78.
78. They had a score of 75, so they're below the mean already.
I see. Thank you, Shauna.
Okay, so negative Z-scores are okay. Negative probabilities aren't. So you don't want to get a negative answer for your normal CDF calculation.
Okay, okay,
But you can put a negative answer into your normal CVR for the boundary.
Thank you, Shauna.
Mhm. Does that answer your question?
Yes, Shauna. Thank you.
Okay. All righty. Did you want me to answer more parts of that question or?
Yes, please, if we can read
Yeah,
through it.
definitely. Go ahead and go back to your screen. And then we'll continue with that. Okay, so that was the first two. So now we have discussion question. Oh, do you want to do it for 160 or do you feel comfortable with that? We did it for the first one, 1763.
So for 160, it would be
The
Zero.
same thing, except everywhere I put 60, you would put 160.
Okay.
That's the only difference.
Do you mind if I share my tablet and try and work it on my
No,
own, Shauna? You can
go
see my
ahead.
work?
Yeah, go ahead. That's fine. We know what the answer should be. It's 0645. Go ahead and add your tablet to the meeting. Do you have it?
Let me punch it up, Shauna. Give me 1 second.
You need the meeting ID?
I think I found it here, Shauna.
Okay. Pulse. Oh, here. There you go.
Thank you, Shauna.
Mm-hmm.
Recording in progress.
Mute your audio.
Oops.
That's okay. I've had plenty of those. Yeah, no, I'm right there with you. Join without the audio on your iPad and with the audio in your computer. You with me? You muted, okay. You've muted your, there you go. There
Let
you
me
go.
try and mute the iPad.
You have to mute the audio on your iPad and keep the audio on your.
Is that better, Shauna?
Mm-hmm.
Okay, thank you, Shauna.
Yeah, that's perfect. Yeah, you have to do it from your device or it doesn't work. But now you need to share your tablet on screen.
Okay, can you see that?
Not seeing it yet. You're still sharing your other device audio. So you need to change your screen share to your.
Stop share.
And then share from your other device. It says you started screen sharing, but I don't see
Yeah, we see
anything
you.
but a black screen yet. Are you sharing the proper window that
I
you're,
believe so. I thought I was.
maybe broadcast the? Let me just. um, Okay, I think now I see something with some marks on it. Okay, let's see. So Z is equal to, okay, I see that. 75 minus, okay. All right, I'm with that.
So now we're
93.
just sigma.
Uh-huh. So the only difference, if you notice, is your N. If you look here,
Mhm.
the only difference, if you look at where it says probabilities and it has a 60 in red at the bottom,
Yes.
if you look down below, you'll see it says square root 160. That's the only difference in the calculation, and that gives you a different z-score. So that's why that happened.
1.9764.
Yeah, that's
Can I
right.
leave it to 4 decimal place and I'll be good, Shauna?
Yeah, that's fine. They asked for that, so that would be the right place to leave it.
So for my z-score, which is again 75 minus 78
Uh-huh.
for new sigma, which is 1.9764.
Mm-hmm.
75 minus 78 divided by 1.9764 is negative 1.52.
Yeah, that's right. Very good.
And now I can go over to my table. Negative 1.52 is 0.0643.
And that's exactly, well, they have 4, 5,
Okay,
but yeah, that's essentially, if you did it with the technology, it would probably come out to be 0.645, but yes.
so if that happens to me in the exam, don't freak out. It's gonna be a minor.
Yeah, uh-huh.
Okay,
There's gonna be minor differences between the table and the TAC, because the tables generally tables only go, the z-scores only go to 2 places,
mhm,
but on your calculator, the z-scores go to 4.
okay. Hey,
And
Shauna,
that,
this one,
go ahead.
if this one would have been greater then I do 1 minus.
No, well, you could, and it's, but I would just change the parameters in the inside, so I would go, if it was greater, it would be 75, comma, E99, the mean 78, and the standard deviation for whichever one you chose.
But as far as like doing it by hand, I would have done, if it would have been greater than,
The
if it would have been,
the z-score would have been the same,
okay,
but you would have chosen to look at the other area under the table, the
yes.
area to the right of the z.
Mhm. And I would have had to do 1 minus to give
It
me that?
depends on what kind of table
Okay,
you're looking at. Some tables have like all three versions where they give you the left tail, the middle, and the right tail? What, on your table, on the chart that you're using, what is the shaded area that you're given?
It's to the left.
To the left of Z?
Yes.
Then yes, you would do 1 minus to get the area to the right. Mm-hmm.
Thank you, Shauna.
Mm-hmm. Good question. Those always depend on what tables you're using.
Okay. The second one says, according to a certain website, wine critics generally use a wine scoring scale to communicate their options on a relative quality of wines. Wine scores range from 0 to 100, with a score of 95 through 100 indicating 90 to 94 indicating an outstanding wine, 85 to 89 indicating a very good wine, 75 to 79 indicating a mediocre wine, and below 75 indicating that the wine is not recommended. Random ratings on a Pinot recently produced by a newly established vineyard in 2018 follow.
Okay, so they gave you all those.
Mhm.
And what do they want to know?
Develop a point estimate of mean wine scores for this.
Okay. So do you know what a point estimate is?
I know we went over it in class, Shauna, but I forgot. It's going to be
It's okay.
something to do with the mean.
A point estimate, because it looks like you're getting into two things here. The first one we did was a hypothesis test. This one is more about estimations and confidence intervals. So there's two ways to estimate something, okay? You can estimate with a certain specific number, or you can estimate by giving an interval, right? And one of the ways that I usually explain this is if you meet somebody new and somebody says, well, how old do you think Shauna is? And somebody says, well, I think she's about 50 years old, right? That's a point estimate. That's a single number, right? If somebody says, I think Shauna is between 40 and 50, that becomes a confidence interval estimate, right? A point estimate is a single value that is believed to be a good estimate for that particular parameter that you're using, okay? The best point estimate for the mean is the sample mean. So what it's saying is treat these numbers that are in the chart as a sample. Find the mean of them. That will be the point estimate. So add them all up and then get the total and divide by how many of them there are. And that should be the point estimate for this.
And to add them up and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
And divide by 12.
Okay. So 87 plus 91 plus 86 plus 82 plus 72 plus 91 plus 60 plus 77 plus 80 plus 79 plus 83 plus 96 equals 984 divided by 12, 82.
That's your point estimate for that particular situation.
Thank you, Shauna.
Uh-huh. I haven't left the room. I just stepped away from my
It's okay.
camera.
It's okay, Shauna. I can hear you. Thank you. I'm taking notes.
Okay, well, the next thing says develop a point estimate of the standard deviation. So the best estimate of the population standard deviation is the sample standard deviation. So it's asking you to find the standard deviation of this sample. Okay, that's all it means. So
Okay.
treat this like a sample and find this. Now, you can do the big long formula, right? Or you could just put this in a list
Right.
and just calculate S.
But it did the first time and it worked out.
Yeah,
Okay.
okay.
Yes, Shauna.
All right, what are we doing here?
Says you may need to use the appropriate appendix table or technology to answer this question. A population has a mean of 200 and a standard deviation of 50.
Mm-hmm. Okay,
Suppose a sample size of 100. So my sample S is 100 is selected and X bar is used to estimate mu. Round your
Okay.
answers to 4 decimal places. What is the probability that the sample mean will be within plus or minus 5 of the population mean?
okay. Now, if you understand what this is saying,
Mhm.
that's the hardest part, because questions are almost never written this way. I mean,
Right.
it's not that it's any harder than number one. It's actually easier to read than number one. Number one had a lot of background information that we needed, but we're just not used to seeing it this way.
Is this a confidence interval, Shauna?
It makes it sound like it is, right?
Yes.
Except that now it is an interval, and that's important that you picked up on that, but that's not the question that it's asking, right? So it says, let me do something here. Let me go ahead and screenshot this. I want to show you something that because I would not have done it this way exactly. I would have said, let me do something here. That will be, I'll put this back up in a second, but let me just, what I'm gonna do first is, I'm gonna do something here. So what it's basically saying is, remember, when in doubt, you try to draw it if you can.
Okay.
So you see, now it's not asking us to find a confidence interval because it doesn't say find a confidence interval estimate. It doesn't tell us how confident we are, right? It doesn't say that. It just tells us how close we want to be, right?
Yes, Shauna.
So in this case, it's saying that the mean, which we know is in the middle because it's normal, the mean is 200, isn't it? Didn't it
Yes,
say?
Shauna. 200. Yes.
So the mean is 200. And we want to be within 5 points either way, right?
Okay.
Well, if we add 5 to 200, what do we get?
205.
Yeah, all right. Don't, and there's a reason why I asked you that question in that way. But the last thing you want to do is overcomplicate your life. So this is 205, right?
Yes.
And if I subtract 5 from 200, then what do I get?
195.
Right, 195. Now, what it's asking us is it's saying, okay, here we are. This is And the only reason I drew these so much longer is so that I could actually label them
Okay,
for you to still see them. But basically what it's asking us is, what is the probability that I'm in here? What is the probability that I'm in this region,
okay,
right? Remember that the probabilities, whatever probability you're trying to find, corresponds to an area under the curve, right?
yes,
So we're in here. So basically what this is saying is, it's saying, if I know that my mean is 200, my standard deviation is 50, right? And did it say anything about my sample? I don't remember.
the sample size is 100, Shauna.
The sample size is 100. The
Yeah,
n is 100. Okay. Then it says we want to find the probability that we're within 5 points of the mean. So basically what it's telling us is we want to do this. We want to be with 195. And then for our purposes here, it doesn't mean, it's not going to make a difference in terms of the math if we write less than equal to or just less than, but I'm going to write less than equal to because that's normally the way it's written. Greater than or equal to. All right. And this is going to be 205. And we want to find that probability. Okay. So again, you have some choices. You can do the z-scores. You can do the z-scores individually, or you can just put this in the calculator using what you know. But assuming that you decided to use the
formula.
see, if you end up using the z-scores,
Mhm.
then you're gonna have to do a bunch of adding and subtracting based on your tables. You know what I mean?
Mhm.
Because if you write for 195, right? For X bar, and this is actually X bar. For X bar, and in this case, you would want to be, of course, you want to be greater, but not the whole thing greater, right? So for X bar, you actually, in this case, the less than is not going to help you very much, right? There are a couple of ways of going about this. If you had a table that was only going to give you this, which you don't want, I might actually do it for 205. So in other words, I would do, based on the tables that you were looking at, I would look at the area less than 205 and get that number, and then subtract the area less than 195. And that would leave me with the area in the middle, which is what I want.
Okay,
If I'm using the table.
right. It looks like that's what they did here, Shauna.
Does that make sense to you? Why?
Because we're looking for the area in the middle.
Because I want the purple area,
Mhm.
right? When I read, so if I have don't worry about the number, don't worry about the actual numbers right now, but in general, if you're reading the if you're reading the tables and you have the mean here, let's say, right? And you have an element over here, let's say this one. And you have another element over here, let's say this one. You want the area in the middle here, right?
Right.
If you read the red area, if you read the red area, it's going to give you all of this.
Mm-hmm.
Okay, it's going to give you all of that. Right?
Right.
Now, if you read the black area, it's going to give you all of this. So if you, whoops. Okay, let me move this out of the way. Okay. Let me see, where am I at? Oh no, it's still on. Okay, I just need my annotation tool. Hello, annotations, there it is.
Shauna, on these, why are we making the adjustment for the standard deviation if it's already given to us? The standard deviation was 50, but we're on.
Remember that the
Sample?
that's for the whole distribution, but you
Okay.
have to, when you have a sample, you divide by the square root of the sample size,
Okay, Shauna, thank you.
right? Because you're dealing with the mean of the sample, not the mean for the individual score.
Okay,
That's
Shauna.
why. But to just finish this up really quick,
Mhm.
where am I? Here I am. This is going to give me all of this. You see?
Yes.
So what I would like to do is, yes, when I read the red part, when I read the red, I'm going to get all of my pink zone, aren't I? But I'm also going to get all this purple that I don't want.
Right.
So what I'm going to do is when I read the purple line,
Uh-huh.
which is what I'm going to do, when I read the purple line, I'm going to subtract it.
Okay. Thank you, Shauna.
That's why. So you read the red one, and it's going to give you the area to the left of the red one, and then you need to subtract the purple one off. So what I'm telling you in short is that the area, the pink area, not the red area, but the pink shaded area is going to be the area to the left of the red line minus the area to the left of the purple line. And this black line is right in the middle. But the black line was there for the mean. That's the only reason I did that, was to separate both sides of this. But you want the pink shaded region. So you read the rightmost area and subtract the leftmost for that. If you're doing z-scores. If you just put in the numbers, you don't have to worry about that.
Okay.
But if you're reading from the tables, you do.
Thank you, Shauna.
Okay,
Okay.
what else we got?
Can I share my tablet so I can try and work it out by
Yeah.
hand?
Yeah, go ahead. You have a test coming up, another one?
Yeah, just next Thursday.
Oh, okay.
I got 3 exams on Thursday, Shauna.
Oh, you again, huh?
Yeah, I got
They love doing that to you. That
human
happened to you,
resources,
that happened to
science.
you, that happened to you last time. You had
Last
3
time it was
exams on
only
the
2.
same day.
Last time it was only 2. This time it's gonna be 3.
Oh, wow, crazy.
Yeah.
Nothing like throwing you in at the last, like, hey, we're glad you're back. Now let's throw all the exams at you
Right,
that you
Shauna?
haven't had. All right, talk to me, my friend.
Well, I'm gonna try and solve these by hand. And I know that my X is 200. I mean, my X bar is 200. My standard deviation is 50, but that's for a population. And my N is 100. So if I want to fix that standard deviation for the sample, that would be my formula up here.
Sigma divided by the square root of n.
Sigma.
What is your sigma? Did you tell me? What is it?
50.
And what is your n?
N is 100.
So what is 50 divided by the square root of 100?
Square root of 100. It's a 5.
Right. So when you put this, either when you put this in your calculator or when you use your z-scores, your sigma that you're going to put in is not 50. It's going to be 5.
Okay, Shauna.
Okay.
So for 5, plus or minus 5, we said it was 195 and 205. So now I need the z-score for the 205, and you said to subtract the 195, right?
Okay, now here, they did 2 separate calculations. Okay, you don't want to subtract the boundaries from each other. I told you to do that when you do the areas. If you're going to do the separate z-scores, you have to do what they did here. So at 205, what they're plugging in is 205 as your X bar, 200 as your mean, and 5 for your sigma of X bar. Now, where did the 5 come from?
The 5 is my sigma, the sample sigma.
Right, sigma of X bar, right. That's exactly right. So if you take 205 minus
200 by 200 over 5.
right.
Yes, 5 over 5 equals 1.
So your z-score at 205 is 1. Now do it for 195. So you have 195 minus 200 over 5.
Uh, 185. It's 185 minus 200 is -5 over 5.
Right, which is,
-1.
so your z-score there is -1, right?
Okay.
So it's asking you for the area between -1 and 1.
Okay. So now I take I look at my table for 1. That would be 0.8413.
Okay, then you do what?
And now I look for the -1. -1 is 0.1587.
Okay, and then what happens when you subtract?
We're looking for the sample mean within the population mean. So that would be 0.8413 minus 0.1587. Yes.
Yeah. Mm-hmm.
And that is 0.8413 minus 0.1587. Oops, you got to log in there somewhere. 0.8413 minus 0.1587. 0.6826. Good. Thank you, Shauna.
Of course.
And now for B, it says what's the probability that sample mean will be between 0.10 of the population mean? So that's 0.10 would be 210 minus 200 over 5. And that would be 190 minus 200 over 5 equals 10 over 5 is 10 divided by 5 is 2 equals -10 over 5 equals -2.
Okay.
And look at my z-scores over here. -2 is 0.228.
Okay.
And a +2 is 0.9772. Now I subtract 0.9772 minus 0.0228.
0.977. Yeah. Mm-hmm.
9772 minus 0.0228. 0.9544. Oh, they got? Yeah.
Mm-hmm.
Thank you, Shauna.
Of course.
You're great. This one I got wrong, Shauna. I don't know what I did here.
You may, okay, Barron's reported that the average number of weeks an individuals unemployed is 16.5. Assume that for the population length of unemployment is 16.5 and the mean is 4. Suppose you would like to select a sample of 50 unemployed individuals for a follow-up. Show the sampling distribution of X bar, the sample mean average of the sample for 50 unemployed workers. Okay. So this is like describe and sketch. What do we need to know if we're going to describe the sample? What is it that we need to have?
We need our mean,
Okay, and
which is our standard deviation.
right now, notice they said show the sampling distribution of X
Oh.
bar, not the distribution of the individual values,
So
right?
now we're looking for sigma sub X bar.
Right, so what is your mean?
I mean is average number, mean length of unemployment 16.5.
Right, so which two diagrams are we automatically not looking at?
The second one is out.
Right, which other one?
This one here.
Yeah. So you just narrowed your choices without doing anything. Now, the bottom two are here, I would guess, to mess you up, because if you forget that you're looking at the sampling distribution, the next thing you're going to say is, oh, they're 50 apart. So I just make sure I'm 50 over, right? Well, well, what is my standard deviation, right? It's a standard deviation of 4 weeks, right?
Shauna.
So some people would look at that and go, okay, I'm looking at a standard deviation of 4 weeks, so I should be 4 units. But that's the sigma, that's not the sigma of X bar, right?
Right, Shauna.
So actually, you can actually do this problem by the process of elimination without doing any work. Now, you're doing the right work, but if you look at the bottom right,
Mhm.
you have 16 and a half in the middle, you have 20 and a half next. They went 4 units, right?
Right.
This distribution on the bottom right does mean something. This is the sampling distribution of X, not X bar, the sampling distribution of X. This is individual weeks. This is the sample average for individual employees. Okay, that's not what they're asking for. This other diagram, which the square root of 50 is going to be somewhere around 7, and 4 over 7 is going to be somewhere about half a unit or so. And so if you look at it, this is about half a unit apart, 16.5 to 17.1, right?
Yes.
So that's why this bottom left is correct. Now, the bottom left is the sampling distribution of X bar, which is what they asked for. The bottom right is the sampling distribution of individual employees.
Okay, so when I calculated it, I can see here that it's going, like you said, 0.5
Mhm.
is my new sample.
So if
size.
you were to add 16.5 plus 0.5657, what would you get?
Plus 16.5, 17.06.
And if you look here, what is it rounded to? 17.1 was their first standard deviation over. You see that? Clyde, you're frozen. Can you hear me? Can you hear me, Clyde? Hello? Hello? Whoops. Clyde, are you back? Clyde, are you here? Let me chat with you. Clyde, can you hear me? Can you hear me? You're really slow, but I can't see you, but I can sort of hear you. I hear something, but it sounds like static interference in the background. Hey, Clyde, what's up?
Hey, Shauna, the Wi-Fi went down in the whole library.
Oh, no.
Yeah, they're scrambling around here trying to fix it, but
Okay, well, you want to give it a couple minutes or? I still have the meeting open. Okay, well, I'm still here. I still have your meeting open. And like I said, maybe it's having a moment. Oh, okay. All right. Well, I'll leave the meeting open until 3:15 because I have another student at 3:30. So, okay. Are you here?
sorry, Shauna.
That's okay. Your other device
Uh-huh.
doesn't show audio. The other device you're on?
I just turned it off right now because I didn't want to get that echo.
Oh, okay. All right. Yeah, I can hear you.
Okay, let me share my
I
screen.
think we're good to go
Okay.
from wherever we were. The loves of technology, right? It says you start, okay, screen broadcast. I see that. However, I don't see anything else yet. Okay.
Shauna, can you hear me there?
I can, yes. I can hear you. Can you hear me? Can you hear me now?
Shauna,
Hey,
I'm sorry about that. Shauna, it's a terrible Wi-Fi here.
I'm sorry to hear that.
Let me see if I share my screen.
We were doing so well a
And,
few minutes ago.
can you hear Shauna?
You're not sharing anything yet.
Shauna, are you here?
I'm here.
Shauna, that was the last problem. I don't think the Wi-Fi app, it's too good here.
Okay. Do you want to try and reschedule for tomorrow?
I can't tomorrow because I have class all day.
How about
That's my long day
how
at
about
school.
Friday?
Friday would be- Friday, sorry, Shauna.
No, you were saying?
We do this weekend so that way it gives me time to work on as much as I can and get ready for the exam.
Yeah,
And
that's
maybe
fine.
we can meet maybe I can go to sister's house or something, or my brother's house on Sunday if you have time. Do you have time on
Sunday?
Sunday?
I can make time for you on Sunday. Just let me know. Just text me and
Okay,
we'll see what happens. Okay?
thank you, Sean. I'm sorry about that.
No problem. I hope you get it fixed, okay? And I'll send you the recording as soon as it's ready. All right, we'll talk later.